So we use the mnemonic silly people drive funny to remember the 4 blocks. It stands for sp, d, and f orbital. Okay? And now we cross off helium and we move it over to the s block. Is everybody comfortable with that? So this whole block is called what block? This whole block is called the s block. So electrons that reside in this block are called the s block elements. Keith, did you do that? Did you label the s block? Remember, those who are here, this whole column, do you see this column? This is S1 and this is S2. Any element that falls in this column will end with what? What will the electron configuration end with? S1. Any element that falls in this column, its electron configuration will end with what? S2. After the S block, it is the P block. Is that right? This block is called the P block. This is the P block. And interestingly, this whole column in P block is P1, P2, P3, P4, P5, and P6. Any element that falls in that particular column will end with that electron configuration. Are we clear? So remember, it's not S and then P. S we skipped in between and then label the P. Do you remember this? SP. What is the next block? The D block. So this in between block is called the D block. And if you start numbering D from 1 onwards, you will find that it goes from D1 to D10. D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. Every good? If we did that? All right. And the last block is your F block, correct? This is your F block. All right, I'm going to write it on the side and call it the F block. And F block will run from F1 to F14. F block runs from F1 to F14. Well, you labeled the columns, but you haven't labeled the rows. Is that right? Right? The electrons are in those blocks. We have labeled top to bottom, but we don't know what is across. Is that right? So we say we need to remember the energy levels. All right? We did the Bohr model before. Remember we drew circles for Bohr model? All of you in class, do you remember that? These energy levels, when you flip your periodic table in the back for a moment and see the periodic table that will actually be given to you, do you see these numbers are already there? 1, 2, 3, 4, 5, 6, 7. So for the S block, the energy levels are numbered for you already. Is that right? But since it's not numbered on my blank periodic table, I'm just going to go ahead and number it on my blank one. 1, 2, 3, 4, 5, 6, 7. Everybody good? Number those energy levels. You should know to recognize them. Now, so there is a pattern here. All right? The block numbering is easy. You start numbering S at 1. If you go across, actually, you won't find the first block for P. There is no 1P. Does everybody realize that? So, the P block numbering starts at 2, 3, 4, 5, 6, 7. Go ahead and write out those numbers before P. Write it big and nice. You can use colored pencils for the different rocks. You can make it colorful and big and nice so that you understand it. Everybody good? Everybody good with numbering? So here is the pattern. S starts at 1, P starts at 2. Where do you think D will start? 3. S at 1, P at 2, D at 3. But it's very important to recognize this. This is 3, 4, 5, 6. Okay? Here is where I would like you to notice. Louis, do I have your attention? After 4S, Keith, are you listening? After 4S, what is the next one? After 4S, what is this number? 3, and what is the block? D. After 4S, it is 3D. After 4S, it is not 4P. Is everybody following in class? You understand this? It's very important to recognize this. Alright? So S started at 1, P started at 2, D started at 3, F will start at 4. So number this 4 and 5. Number this 4 and 5. Alright? Now, you know how we drew those boxes and we drew arrows within them? Alright? Remember that whenever it is an S orbital, you will draw how many boxes? 1 box. And how many total electrons going to go into S? 2. And those are the 2 that will go in, right? The S1 and the S2. Is that right? So you draw an up arrow and a down arrow. And that's the S block. Everybody understand? Whenever you draw a P block, can anybody tell me how many boxes you will be drawing for P? How many total number of electrons can go into P? 6. So how many boxes do you think you will draw? No, 2 can go into each box, right? So how many boxes for P generally? 3. And those 6 electrons will go up and then down. Yes or no? Remember this? How many total electrons can go into D? How many total electrons can go into D? So how many boxes do you think you will draw for D? 5. Alright? For D, there are 5 boxes. 1, 2, 3, 4. 1, 2, 3, 4, 5. And they will occupy the D box one at a time before they double up. Right? So F, are we writing this down? Are we drawing boxes and saying how many boxes we draw for each? For F there is 1 box. For P there is 3 boxes. Draw that on top. It's a nice visual when you look at the periodic table that you will remember it. I need you to draw those boxes. Alright? Right? Draw those boxes down so that you know how many boxes, so that when you look at it, you remember it. How many will you draw for P? 3. And I'd like to see that. And for D, I'd like to see the 5 boxes. Okay? Everybody good? Alright. So the next thing is the F block. Can someone tell me how many boxes for F? 7. Right? Because there are a total of 14 electrons. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And you can fill it in with your electrons. Alright? Everybody good with the number of boxes we can draw? You should be able to do this on your own. So, did we understand how to block off the periodic table in order to write the electron configuration? Are we comfortable doing that? Okay, go to the back. All of you go to the back. All of you go to the back. This is the real periodic table. So, when you get this periodic table on your quiz, on your test, you should know how to block it off. Can we do this again independently. You just learned it. While I'm doing it, can you do it on your paper? Can we do this quickly? So what is the first thing I will do? Cross off helium and put it there. And then I will call this block what? I'm going to call this my S block. Alright? And then I'm going to block this one off. I'm going to call it my P block. I'm going to block this one off and call it my D block. And then I'm going to block this one off and call it my F block. And then the next thing I must remember to do is I need to write out the energy levels. For the S, it's already done. S starts at 1. So P starts at 2, 3, 4, 5, 6. And then D starts at 3, 4, 5, 6. And then my F starts at 4 and 5. So if given a periodic table, you should be very comfortable doing this on your periodic table. Are we good? Write down the blocks and write down the numbers. The numbers are especially important. I need you to write this big and bold at the end of each block. Do this, otherwise you will get lost in this process of writing the electron configuration. Are we good? Okay. So now, the way I would like you to learn writing the electron configuration is, do you have this worksheet with you? Alright? I need you to put your periodic table in front of you and this sheet under, together, just like the way Yutaka has put them, one below the other. So that you can use the periodic table to run your finger and write your electron configuration. Have the two sheets, one besides the other or one on top and below, however you like it. But you should have both the sheets alongside each other. Everybody good? Okay. So, please understand, are you all listening? And as I teach you to write electron configurations with the periodic table, for some students it will click immediately. They're like, yeah, we understand what you're doing and we get it. Some students for the longest time will be like, I don't get it. And then suddenly the light bulb will go and they get it. So we are going to do some practice problems together. Is that clear? If you are not understanding, you need to put your hand up and tell me you're not following. Is that clear? Okay. So, my very first element is lithium. Is that right? My very first element is lithium. And lithium has, if lithium is neutral, lithium has how many electrons? 3. So I need to account for the 3 electrons. I'm going to go to my periodic table and I'm going to use it. Okay? Where is lithium on my periodic table? I see lithium is located right here. Is that right? So in order to write the electron configuration, you read the periodic table like you read sentences in a book. Did you hear me? In order to write the electron configuration, you read the periodic table like you read sentences in a book. When you read a sentence or when you start a page, where do you start? At the top. And how do you read? From left to right. And then where do you come back? To the left. And then you go all the way to the right. Is that how you read it? You start at the top. So every electron configuration is like a page. You start at the top. You go left to right. Alright? You come back to the left and then you go to the right. Are we clear about this process? So, lithium What is this first energy level? You have to write the energy level first. I'm going to write lithium here. What is the energy level? 1. All of you can write that for lithium. 1. After the energy level, what is the block? What block is this? S. Am I crossing these two blocks before I come here? So both these blocks are crossed, so it is S2. Did you all write 1s2? Besides on lithium, did you write 1s2? What do you write first? The energy level, the block, and you cross them both. Is that right? I've crossed these both. And now, I'm going to run across to the periodic table. Do I have a 1p? Do I have it? No. So I end here, I come back here. Right? I'm reading the next line. What is the first thing I need to write? 2. What is the block number? S. Does lithium stop here? What block is this? What block is this? Is this S1? This column is S1. So what should I write? 1s2, 2s1. Do you understand how I wrote lithium's electron configuration? Everybody follow this? Alright? What is your... So I'm going to go back and I'm going to write out lithium's configuration was 1s2, 2s1. Right? Oxygen. Oxygen has 8 electrons. And I'm going to go to oxygen now. Alright? I'm going to go to oxygen. Did you guys locate oxygen on your periodic table? Okay? So I have to start at the top of the page. Is that right? Oxygen's electron configuration. What do I do first? Write the energy level, which is 1. What is the block? S. How many in S? 2. 1s2. There is no 1p. Is that right? I come down. What is this energy level? Louis, stay with me. 2. What is the block? S. How many do we cross in S? 2. What do I come down next to? What do I come down next to? What is my energy level across? 2. But what is the block now? P. Where does oxygen stop? 1, 2, 3, 4. Did I just write down the electron configuration without those boxes and arrows? Do you understand? If I know to block the periodic table, I can write the electron configuration. Do you understand? Shall I do one more and then you will practice a few and then we'll see if you're getting the same answer? Alright? What is the next element? Calcium is a long one. I want you, let me do calcium. Calcium is 20. Did you write down for oxygen and lithium? Is the answer there on your sheet? Alright, you're doing the next one, which is calcium. Okay? And where is calcium on my periodic table? Right here is calcium. Who wants to help me between the three of you? I want one of you to help me. Who's going to help me? Huh? Look at that. That's not right. Who? You all understood, right? All three of you understood? I need... Yutaka, you'll volunteer?
Sure.
Sure. There you go. When you boys need to write with me. All right, calcium. Yutaka, help me here. So calcium is 20. That is correct. So how do I write the electron configuration for calcium? 1s2. 1s2. 2s2. After 2s2, I crossed out 2s2. 1, 2, 3, 4, 5, 6. It's 2p6.
2s. We got 3s.
3s2. 3s2. 3p6
And 4s.
4s2. Do I need to continue or should I stop? Stop. Okay, good. Everybody understood it? Everybody understood electron configuration? All right. Any questions, anybody? Yes, Mustafa.
What do you put in the diagram?
Oh, that I will teach you in a little bit. All right. So
Does
let's
everybody
do.
see- Can you back up just 1 second?
Sure. The
And does everybody know how to check it? If you add the 2 plus 2 plus 6 plus 2 plus 6 plus 2, what do you get?
what is Miss Lee saying? If you add all this, what should you get? The number of electrons. It should be 20. That's a quick way for you to check if you've included everything. Guys, writing electron configuration, you have to be very, very correct. Like if you tell me 1s2, 2s2, 2p6 and suddenly you want to put it as 2s2 back here, do you think I'm going to give you any credit for writing the electron configuration? I will recognize that and I will strike off the entire configuration. You will not get any credit for it. Do you understand? You really have to practice. Yes, Stephen?
What if it's like the excited electron?
We will give it to you that it's excited. That's a very good question. What are we writing? It says, what does it say? Does it say ground state electron configuration on your sheet? Does it say that? So we are writing the ground state electron configuration. Is that clear? So I did it for calcium. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Is that right? I want you to do it for nitrogen, potassium, chlorine. Hydrogen is darn easy. All right? Let's do it. Let me give you about 5 minutes to write out these electron configurations. And then I'm going to check the answers with the class. I'm going to write it on the board and check it. If anybody needs help, you need to put up your hand and ask me for help. I'll come around and help you. I need to see you all work through these problems. Come on. Yes. Tissue. There. I see one here. I need all of you to be doing this. Can we do one together? Okay, write it down. Alternate the each. I want to do three for oxygen. You always need to start at the first. What number do you have in box? And what block is it? And how many always start at the top of the page. What is it? One. What is the block? One. Right one. What is the block? How many will be? Two. And then there is nothing across, so we come down next to it. What are the blocks? There are two. What is the block? And how many will go into two? Two. So right two. What is this block now? Okay. Right? Three. Okay. Do the task. Where do you start? Okay. Wait. You have to go left to right if you're in the hood. Okay. And then there is no 1B, so you come down. Okay. And then I'm reading the book. I'm reading sentence. Okay. One, two, three, four, five, six. Okay. And then. Okay, three. Right now. We are in task. Go down to the hill. We haven't reached the top. Okay. And then we go across. Very good. It's not here, so we still have to finish this line. So what will that line be? What? Six. How do you write that? Very good. Now we come down here. What is that? So what will it be? Very good. Yeah, I get you. Okay. Do you need more time? Did you finish it? No? You need some more time? Can I give you like 2 more minutes? All right. I'm going to give you 2 more minutes. All right. Do the problems. Aiden, are you okay? Do you need some help or are you okay? You're fine. So where do you start? You start at the top of the page. So right now, what is the first one? One, minus, and how many will go here? Minus, how many electrons will go here? Three. Go across the zone. Okay. And you come here, what will have this piece? So two, so two. What is the block? And how many will go here? We are doing nitrogen. So what's the next one? What is this energy level? 2p, there are 2p, and where does it start? Which is not test. You always have to start at the top of the page. And you have to keep reading your sentences till you reach that spot. So like now, what will it be? Okay, so what will it be? And there is no one here, so what is this? And then
We skipped on we skipped the 4 plus 6. Yes, it's 4x2 and 15.
Good.
Copper, you need to get three copper.
Do copper. Do copper. All of you should have done copper. Copper is a little difficult. I need you to follow copper. I need you to do copper. Those of you who are good can move on to the homework problems maybe. As you're giving students more time, you can maybe try your homework problems. Huh? We are going to do that. I would like you to try these homework problems. Yeah. And I need you to go back and check copper. Copper is not written correctly. And I need you to yeah, there is no remember it starts with school. Such a easy one. Yeah. Huh? Really good job. Good job. Okay. I'm waiting on you, boss. Hey, I'm waiting on you, boss, to do copper. Get copper now. You did copper, kids? You took that? Yes, very good. Do copper, Nibe. Good. I'm just waiting for the two of you. Oh wait, this is a bad recording because guess what? I didn't stop it at all. Actually start recording now. Alright? So nitrogen should be 1s2, 2s2, 2p3. Everybody got that? Potassium is 19 and you should get 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Got that? Chlorine is 17 and you should have 1s2, 2s2, 2p6, 3s2, 3p5. Everybody good? Are you checking your answers? Hydrogen is just 1s1. Hey, the all important copper is 29. Can we go to copper? It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Let's go to the periodic table. Alright? What comes after 4s? After I cross 4s, what is my next number? 3, D, where does copper end? 9. So after 4s, can you write 4d? Will that be correct? 4s, then 4d. Is that correct? After 4s, what will you write? 3d. If you write after 4s, 4d, your entire configuration is wrong. You understand? Alright? So this will be 4s2, 3d9. You understand? Now, copper unfortunately does not like to follow rules. Alright? I teach this in my honors class. Copper is an exception. Copper is what? I'm not going to test you on exceptions. Is this class listening? I'm not going to ask you for exceptions. If you write this as copper's configuration, what am I going to say? Yay, the student did it right. I'm going to give you full credit. Alright? But there are a large number of really strong students in this class. So I'd like to share the extra information. Alright? Copper does not like to follow rules. Copper is an exception. So the actual configuration for copper is 4s1, 3d10. It is not 4s2, 3d9. It is 4s1, 3d10. Because it becomes more stable if it has a filled, D can occupy a total of 10. Is that right? So copper becomes more stable that way in its electron configuration. I'm not going to test you on copper. but it's just extra information out there for you. Okay? There are a number of elements in the periodic table that will not follow the rule. Okay? And copper is just one of them. Alright? Let's go to neon. Neon is 10. And so you'll have 1s2, 2s2, 2p6. Is that right? Phosphorus is 15. Did you guys recognize the difference in symbol between phosphorus and potassium? What's the symbol for potassium? K. What's the symbol for phosphorus? P. You should remember this, alright? And phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Correct? Yes or no?
Yes.
You get this? Okay. A lot of kids are interested in abbreviated configuration. It was in the homework packet also. Lois, get this out and listen to me now. Abbreviated configuration. What does the word to abbreviate mean in English? What does the word to abbreviate mean? To abbreviate means to shorten. What is it? To shorten. So you are going to write, what does the word abbreviate mean? To shorten. Alright? It's, did you write, did you underline it, and did you write shorten on top? Did you write the word shorten? Did you do it, Keith?
Yeah, shorten, yeah.
I'm not writing it for myself. I'm saying it so that you remember it. You will see this word. Write the abbreviated configuration. I don't want you putting up your hand and saying, what does that word mean? I'm not going to help you. You understand?
Yeah,
It is also called noble gas configuration. What is it called? Noble gas configuration. That's the other word for abbreviated configuration. If they say write the abbreviated configuration or write the noble gas configuration, it is one and the same. Do you understand? Louis is so tired. Okay. Did you sleep, Louis, last night? Okay. He generally doesn't get enough sleep. That's part of his problem. Nibe doesn't believe it. Do you believe it, Nibe?
No.
He just wants to tease him. That's all. I believe you.
He was texting me until 3 o'clock in the
No,
morning.
I wasn't. It's some girl, it was a Vita as
He
well.
was texting me.
Someone with that right purple.
Huh? What is it? What did you say? I didn't get
It's a
it.
Vita.
What did they say? Is it inappropriate in class?
He got punched in the face by a girl.
Is it inappropriate in class? Okay, I will catch on to it.
No,
My eyes are on you.
it's not.
What is this purple thing around the neck? I didn't get that. I am gonna ask for help.
It's not around. It's never going.
Okay. Okay. I wish Miss McGrain were here. Do you, Miss Lee, do you know what that means? Me neither. You know, we'll catch on to it, don't worry. Alright? We'll learn. We have our learning curves too, right? Every day it's new vocab. Have you gone to Urban Dictionary? They call me a dog one year. You dog? And I'm like, you don't call me a dog. And they're like, no, Ms.Geeta, it's not D-O-G dog. It's D-O-W-G dog. Alright? And I'm like, what's the D-O-W-G dog? And they're like, that means you're my friend. You dog. I'm like, don't you call me a dog again. But I learned something in class. Alright? Yeah, that happened. But you boys should not text each other at 3 in the morning.
No, I was like, shut up.
You were awake at 3 to know he texted at 3.
He woke me up.
I don't wake up for texts at 3 in the morning. Hey, Louis, you're good with technology, correct?
Yeah.
Aren't you good with technology? Can't you like push the button so that it says do not buzz when it texts?
It's not Skype, it's iMessage.
iMessage, hey, you can turn off notification. Can you or can you not?
Not for a Vita.
You can turn off notification for text. Yeah, right? At night when you go to sleep, if it's going to buzz, don't you turn off notification? You better turn off notification.
No, I don't.
And then you can, when you get up in the morning, you can turn it on again.
No, because what if it was important?
3 in the morning, you're with your parents. Who's more important to you? Do you have a girlfriend out there who will text you at 3 in the morning?
It's not what's on my.
What do you get at most? You get something from eBay. I think you can ignore it.
The girlfriend.
No, I didn't do that. I didn't do that.
He won't lie.
I didn't do that. Nope.
You kissed me.
When did this happen? We'll talk about it later. All right.
Yeah, that's what this is.
Can we get back?
Chill out, hold me no dog.
What does the word abbreviate mean? To shorten. Louis, we are back on class. Abbreviate means to shorten. Nibe, are you on your phone?
No.
Is it on your lap? See, it is right there on his lap, and you lie.
Look at him.
It was there on your lap, and you lie.
Look at his ear. Look at his ear. Look at his ear.
Put it out.
Take the hood down.
Put the hoodie down. And you should be like this for the rest of the class. If I see you be on your cell phone, Nibe, I'm dead serious. I'm going to take it away from you.
Yeah, then you can't text me.
All right.
I don't touch my room.
It should go inside. Do you hear me?
Alright, I'll-
My rules are my rules. Okay? Now, shh. Put it away.
Look at
I'm
his
putting it away.
Right now, put it away. Okay. Abbreviated means to shorten. It also means noble gas configuration. All right? So, I need you to go to your periodic table. Are you all on your periodic table? Everybody on that periodic table? All right? So, on your periodic table, this column here, this very last column is called noble gases. What is it called?
Noble gases.
Noble gases. All right? Now, these gases are unreactive gases. All right? They don't react. You can see birthday balloons filled with helium and all that. Is that right? They were discovered way back in the 18th century. All right? And in those days, we were ruled by kings and queens. Is that right? Kings and queens had so much money, they didn't need to go around and mix with ordinary people. Is that right? They lived in their own palace. They had their servants. They had everything they needed. And people didn't know who lived in that darn big, huge place. All right? Maybe they could look at it from outside the door. All right? A huge gate. Now, so when noble gases were discovered, or these gases were discovered, and they didn't react at all with any other element, what did scientists then do? Ha ha ha, let's call them noble gases, like the noble folks. They don't mix. All right? So the name stayed for so many centuries. Does that make sense? They're called noble gases. Anyway, noble gas configuration is the shortened configuration. Is that right? So, imagine that you are trying to write the configuration for the element barium. It will be really long. Do you guys agree? You start at the top, you have to keep going back and forth, back and forth, back and forth. It's too long. So how do you write the shortened configurations? So the first thing you have to check is barium falls in which period? Period 6, right, Keith? Barium is in period 6. You go to previous period 5. You go down and you locate the noble gas. What is the noble gas that period 5 ends in? Xenon, right? So if I'm going to write the abbreviated configuration for barium, which has 56 electrons, I'm going to write xenon in square brackets. Do you have barium here? Do you have barium here? Do you have barium? I want you to write those things with me as I write it on my periodic table. What will you write first? Xenon. Everybody got that? Okay. Now, we are in xenon And then we start writing the configuration from xenon on. What is the energy level? 6. After xenon, what do you write? Nibe, follow along. After xenon, you write 6. What block is this? S. Where does barium end? S2. I'm done with my electron configuration for barium. It's xenon 6s2. Is it a shortened electron configuration? Do you understand it? Did you write it down? Or did you locate barium? Did you locate barium? Here is barium. Write in 6 and write what I wrote up top there. Xenon 6s2. Okay? Did you locate it? Barium is here. Okay? Not zinc. Right against barium and complete that electron configuration. Okay? Alright. Shall we do another one?
Yes.
Let's do, which one do you want me to do from this list? Can we do zinc? Shall we do zinc? Or we are going to do zinc? We're going to do the abbreviated configuration for zinc. Where is zinc located on the periodic table? Where is zinc located? Here is zinc. What are the steps? What are the steps involved? What do I do? I first find what is the period number, right? Zinc is in which period? So what do I go to? Which period do I go to? What do I look for? The noble gas. What is the noble gas in the period before zinc? Argon. Jackie, zinc. Yeah. Are we good? Louis, tell what I did. What did I do now? For noble gas. You know it or you don't, Louis? Or do you know it? No, you don't? Nibe, do you know it? Keith, help us out. What do you do? So this is zinc. Alright? I went to zinc. Zinc is in what period? 4. Then what do I do, Keith? You go up and you come down and you find the noble gas. It is argon. Alright? So for zinc, what should we write first in square brackets? AR, argon. Write argon. Did you locate zinc? Did you write argon in square brackets besides zinc? Did you do that? Did you locate zinc? Okay, after argon, what is my next energy level? 4. 4s2. 4s2. What comes after 4s? 3d10. And that is my noble gas configuration for zinc. Helium, you just do 1s2. Helium is stupid, alright? And I shouldn't have asked that on your paper. You just write helium is 1s2. Okay, I'm going to do one that's not here, alright? I want you to write the noble gas configuration for argon. Argon itself is a noble gas. Yes or no? You cannot write a noble gas as its own electron configuration. You cannot say AR is the electron configuration for argon. That is just wrong. Alright? So what do? You pick the previous noble gas. Alright? You pick the previous noble gas. This is argon, right? What is the previous noble gas? Neon. So you pick neon and then you fill it in. What comes after neon? 3s2, 3p6. That will be argon's electron configuration. If they give you a noble gas, you should know how to write an electron configuration. So let's see. I want you to do it for bromine, magnesium, Bromine and fluorine are same. So let's do it for iron. Iron, bromine and magnesium. Go ahead and write out the noble gas configuration for iron, bromine. Okay, so